sequences often are derived from figurate numbers. And think about it, a figurate, what word does it seem like? The word figure, okay? And from geometry, from the study of geometry, you know you have triangular numbers. We have square numbers. The square numbers are the numbers that we're probably the most familiar with. We have the sequence 1, 4, 9, 16. And the triangular numbers are, what, 1, 3, 6, 10. I mean, you don't need to copy these down. These are in your textbook. But I just wanted you to know when we talk about figurate numbers, we're talking about figures. We have pentagonal numbers and hexagonal numbers. And the pentagonal numbers aren't quite as easy or as obvious to see. But if we look at them, the sequence is, if I start with 1 and add 4 to it, I have a 5. If I have a 5 and then I add the next ring, I would have 12, etc. They're just giving you an example of pentagonal and hexagonal numbers. Okay? All right. All right. So I'm going to give you the vocab in a second. We're just talking about figurate numbers.
Have to write down the
No. I mean, I want you to know that a figurate refers to a number that is in the shape of a figure. So I could have a square number,
So
right?
it's
Or a
one.
triangular number, or a pentagonal or hexagonal. All right? So the vocab that I do want you to know is we're going to be talking about a sequence. And a sequence is an ordered list of numbers. We're going to be talking about terms. And again, a lot of this refers back to geometry, and I think that when you'll see in a second, we're talking about each particular number in a sequence. And we can use a variable with a subscript that gives the term's place in a list. I'm going to give you an example. So if I have 1, 3, 5, 7, do I have a sequence? Is it an ordered list of numbers? Okay, I have 1, 3, 5, 7. And for instance, this is my first term. This is the second term, third term, etc. And I can refer to the first term, which is 1, as I can use a variable and say a to the first subscript. Okay, I'm sorry, I should have read that as a subscript 1. So you know that if I use this, I am talking about the first term. If I'm talking about 3, 3 is which term in the sequence? What is it? Isn't 3 the second term? So I could refer to that as a sub 2. Okay, and the third term is what? 5. So I could refer to that as a sub 3. How about the nth term? What might the nth term be? A sub n. So the nth term would be a sub n. Okay, and this is really important that you understand this notation because we're going to be talking, we're going to generate some rules, and my expectation is that you can use the proper notation. Okay? So we're going to be talking about a sub 1, we're talking about the first term. A sub 2, we're talking about the second term, and a sub 2 happens to be 3. Yeah?
What did you mean when you said run the nth term?
If I ask, and we're going, I could ask you, could you predict a to the nth? I don't know what that is. So I'm going to be asking you to be able to either give me the sum of a term. I'm going to ask you what is a to the 10th, or a to the nth, we are going to generate a rule. Okay, we're gonna come up with a rule. Remember those rules in geometry? The beginning, the very, very beginning. Okay. All right, so could we have an infinite sequence? When you think of an infinite sequence, could we have positive odd integers or, you know, the negative odd integers? Wouldn't they, you know, extend infinitely? Okay. That is what we are.
Is that N?
I'm sorry, what?
Is that NTA or N plus A?
A general term is n to the th, the nth term,
Oh.
and that would be a to the sub n. Okay. Is everybody good with this page? Because I have just a few more to,
Wait,
I'm sorry, a
Wait.
few more.
Wait, for the infinite sequence, positive odd integers, is that?
Is an example.
Oh, okay.
It's just an example. Could you think of another infinite sequence? N plus 2 would be an infinite sequence, that's right. Okay, all right.
Because like 1, 4, 5,
Okay, so, I mean, we can have infinite sequences, and we are going to be talking about infinite sequences eventually. All right. This is a definition that is really important that you understand. We're going to be talking about arithmetic sequences in which a constant, d for this purposes, is added to the previous term. As I said to you, later on we're going to be talking about geometric sequences, but an arithmetic is when something is added. Here's your connection. It's added, this starts with A, this starts with an A. Okay? In elementary school, when you first start arithmetic, you usually start with addition. So you need to kind of make sure that you have that link together. So an arithmetic sequence is in which a constant is added to the previous term, and the constant is called a common difference. I'm going to give you an example. The constant is called the common difference. And you guys have all done this in geometry, okay? And if I said to you, what is the common difference? I need to back up a little bit? Yeah. Sure. You good with that? The constant, do I have to go back beyond, a little bit further back? Okay. An arithmetic sequence is a sequence, you know, in which a constant is added to the previous term. The key idea is that this constant is added, and this constant is called the common difference. Right? Okay. You okay, Eli? Okay. And here's an example. So does everybody remember doing these problems in geometry, you know that, can you come up with the rule for the nth term?
Yeah.
So I look at my sequence, and I think in geometry, it probably was written, this is your first term, your second term, your third term, your fourth, your fifth, and the nth, and the 20th. Does that ring a bell to all of you in geometry? Okay, so I know when n is 1, when it's the first term, and it has to be a 5, I could generate a rule here, yes? Anybody remember how to do this? So I know that the difference is 3, so 3 is going to be what? 3n plus 2. Okay, so when n is 1, 3 times 1 is 3, plus 2 gave me a 5, 3 times 2 is 6, plus 2 more is 8. I can generate a rule, okay? But we're going to generate and learn a different rule today, okay? You know that this is one way to come up with a rule. We're coming up with a different one today, okay? And it's very similar we've done. Okay, and here is one more definition that I want you to do. It's called a recursive, it's a recursive definition or a recursive rule. And it's a rule that tells how to find a term using a previous term. So that's a definition of, a recursive definition is a rule that tells how to find a term using a previous term. Okay, and in this case, you can see, when this is the rule that we just generated for that sequence, do I know what the previous term is? No, I don't. Okay, and so this is just using slightly different information to come up with a rule. Okay, so here we go. We're back to the same numbers, 5, 8, 11, 14, and 17. So why don't you write this down? And we're going to talk about the rule now. Do I know what the first term is? Okay. And I would like you to, let's say I want to know what the sixth term is. Okay. And I don't know what that is, but if I happen to know this is my 1, 2, 3, 4, 5. What? I just need to add 3. I know that if I'm asking you to find a to the 6th, the 6th term.
So it'd just be like.
The 5th term is what? The 5th term is 17. Okay, 17 plus 3 is 20. Okay, so this rule that we're coming up with is based on knowing the previous term. So in this case, my rule is a n minus 1, because if I wanted the 6th one, I need to know what the 5th one was, and then I'm going to add 3. Okay, so is everybody okay with the notation so far? Okay. Supposing let's just look at this.
Wait, no.
Okay, sorry.
Miss Al, I have a question.
Yes,
Why is the n subtracted 1 again?
because if I'm looking for the 6th term, I need to know what the 5th term is. So it's a minus 1 is the 5th term. So if a to the 5th is what, 17? It's going to be 17 plus 3. How about if I want, let's try, how about a to the 4th? I didn't know the answer.
So it'd be a to the 3rd.
It would be 4 minus 1, which is a to the 3rd. A to the 3rd is what, 11? 11 plus the difference
Oh, I see.
is 3, so I'm adding that to the 14th.